So today we're going to be learning about factoring numbers. So the definition of factoring is like splitting up a number into its multiples, which is things that can be multiplied together to get that number. So for instance, do you guys know what any multiples of 10 are?
5 and 2.
Yeah. So 5 times 2 is 10. Exactly. And then there's 10 and 1, because that always works, like a number.
That is a factor of almost every number.
It is, of every number, yeah. So as I said, factors are another word for multiples, or numbers that can be multiplied together to get that number that you were trying to get. And so here is a very big chart of a whole bunch of numbers and all of their multiples. There are also numbers that are just A and B. And so you have to figure out what those numbers would be, I believe, in this chart. Figure out by whichever numbers are multiplied by that to get the final answer. So 12, for example, two multiples of 12 are 3 and 4. So 3 times 4 is 12. 2 and 6 are also able to be multiplied together to get 12. And then 6 and 7 are able to be multiplied together to get 42. So today we're going to learn about a bunch of the rules to easily find which factors are able to go into every number. So before we start, there are such things called prime numbers. So it's a number that's only divisible by 1 and itself. And because every number is divisible by 1 and itself, it's the ones that are only divisible by 1 in itself, and no.
So they wouldn't be called factors?
They are still called factors, yeah. But the number itself is called prime.
Oh, got it.
Yeah, the factors are still factors, and then the number itself is prime. So 3 is a prime number because there's no whole numbers that can go into 3 other than 1 and 3. So itself and 1. Do you guys know any other examples? If you can think of any.
7, 1 and 7?
Yeah. 7. Yeah, exactly. So 1 and 7, but nothing else can be multiplied.
Like most prime numbers would be odd numbers. Most of them.
Yeah, most of them. Like 9 isn't a prime number, but it's still odd.
Yeah.
Yeah. But
that logic doesn't apply always.
Yeah, we're actually going to learn about how every even number is not prime. So it has to be odd in order to be even considered to be prime. So we are going to learn about how to factor each of them by certain numbers. So if a number is divisible by 2, then it's even. So any number that has a 0, 2, 4, 6, 8, and then starts over 0, 2, 4, 6, 8, 0, 4, 2, 6, 8. So any number that ends in a 0, 2, 4, 6, 8, if it's even, then it's divisible by 2.
I don't get it.
So for example, 2, well, 2 is divisible by 2 and 1, but that's a little bit of a strange case. 4, for example, is divisible by 1 and 2, because 2 times 2 is 4.
Yeah.
And 6, you can divide by 2 to get 3. And 8, you can divide by 2 to get 4.
So basically, the number has to be even. The number has to be even to have a factor of 2.
Yeah. Exactly. Yeah. And every number that is even has a factor of 2. So if it's even, you know that it's divisible by 2. So you can just easily find out, oh yeah, 2 is able to go into that number because it's even. And then 5, on the other hand, is a little bit trickier. In order to be divisible by 5, a number has to end in a 0 or a 5. So, for instance, 15 is divisible by 5. Is 17 divisible by 5? No. 17 is not divisible by 5. Is 30 divisible by 5?
Yes.
Yeah. So do you guys understand that any number that ends in a 5 or a 0, so 25 is divisible by 5, 35, 40 is divisible by 5.
Well, wouldn't 17 technically be able to be divisible by 5 because you will get not a whole number?
Yeah, that's true. But then it wouldn't really be divisible by 5.
Yeah, the factors that we are talking about right now are whole numbers.
Okay.
So it is divisible by 5, but not in like talking about whole numbers. We're trying to see if you're able to divide it by 5 and then have it get another whole number. So 0 or 5. If the number is divisible by 3, then the sum of the digits will be divisible by 3. So if you have, for this example, they have 375 is divisible by 3 because the sum, which is adding up the digits of that number, 3 plus 7 plus 5 is 15. And 15 is divisible by 3. But that's a little harder to know. You could always add up. Yeah, but it's a lot easier because then you have a much smaller number to test if it's divisible by 3. If you don't just automatically know that 15 is divisible by 3. So let's see. Is 27 divisible by 3?
Yes.
Why?
Because 9 times 3 will be 27. Its factors are 9 and 3. So it is divisible by 3.
Yeah, but if you're using this method, then you're adding the 2 plus the 7, and that gets 9. And 9 is divisible by 3. You see how that works?
Yeah.
And so, okay, and 6 is a little bit odd of a case. In order to be divisible by 6, it has to be even, so be able to be divided by 2, and the sum of the digits must be divisible by 3. So it uses both of the rules of 2 and 3. And so if only 2 works, but 3 doesn't work, then it's not divisible by 6. But if both work, then it is. So let's see. Again, is 27 divisible by 6? Using the rule.
No, because it's not even.
Exactly, yeah. So
Right.
it is divisible by 3, but it's not divisible by 2. So it can't be divisible by 6. What about 36?
36 is divisible.
Yes.
And why is that, Gayatri?
Because it's, first of all, it's even, and if you add up 3 plus 6, you get 9.
Exactly, yep. So it's even, and if you add the digits together, then it's 9, which is divisible by 3. So it's divisible by 6. Exactly. So all these rules will make it a lot easier to find which numbers a certain number is divisible by. Okay, so for 9, if a number is divisible by 9, then the sum of the digits has to be divisible by 9. So it's very similar to 3, but it's just a bigger number that it has to be divisible by. So let's see, for instance, the sum of the digits is divisible by 9. Let's say 81 the digits divisible by 9?
Yeah.
Because then it will equal 1.
Yeah, exactly. So 81, 8 plus 1 equals 9. And is 9 divisible by 9?
Yeah.
Yes, exactly. So you just add up the digits, very similar to 3, and see if that number is divisible by 9. So more examples. Do you know any of the factors of 252?
2.
Yep. You can always start with 1, because 1 is always going to be true. And then what is 252 divided by 1?
252.
Yeah. So two of the factors that you can even start with are 1 and 252. What else?
252 is is 6 divisible by 2?
No,
But if you add 2,
it's not even.
Yeah, it is. It is divisible by 6.
Right.
Because if you add 2 plus 5 plus 2, you get 9. And
Exactly. And that's divisible by 3. And it's also divisible by 2 because even, right? You also have 4, but 4 is a little harder of a rule. Do you have 5?
No,
No.
because it doesn't end it with 0 or 5.
Do you have 9?
If you,
I don't think so.
Do you guys remember the rule for 9?
I think it's 9
No, I don't think so.
because the
Can
sum
you
of the
go
digits
back to the
is
rule of 9?
Yeah, so 9, in order to be divisible by 9, the sum of the digits has to be divisible by 9.
Yeah, 9 divided by 9 is 1.
Yeah,
Yes.
add 2 plus 5 plus 2, which is 9.
Then
5,
you
6,
divide it.
7, 8, 9. And 9
Okay.
is divisible by 9. Yeah, exactly. So, and then in order to find the other side of it, then you just divide it by each of those numbers to see what the other multiple is, but you know that it's divisible by all those. And what about 211?
Is it? Yeah, 1 and 211.
I don't think it's divisible by 2. That's not even.
Yeah, it's not even, so it's not divisible by 2. Is it divisible by 3?
Yes. No. Wait.
No.
No.
The sum of the digits.
Because if you add up the digits, you get 4, and 4 is not divisible.
Exactly. 4 is not divisible by 3, and it's not even.
Yeah.
So is it divisible by 6?
No.
No.
Because 6, if you want a factor of 6, it needs to be even. But that's not even.
Yeah, it needs to be even and divisible by 3. So is it divisible by 9?
No.
Let me see.
Exactly. It's
Yeah,
not
no.
divisible by 9 because 4 is not evenly divisible by 9.
Well, one factor is 1.
Yeah. 1 and 211.
Exactly.
Yeah.
So this one's actually a tricky one because 211 is prime. So the only numbers that are divisible by is 1 and itself.
Oh, that tricked me.
Yeah, it's tricky. Okay, so one method is called a rainbow method to find what the factors are. So what are all the factors of 15?
5,
5 and
1.
15.
yeah,
Yeah.
exactly. So 1, 3, 5, and 15. So in order to write out all the factors, you can start at 1 and find all the lowest factors that you can find of that number, and then once you can't find it anymore, then you see what that last number, so the 3 in this case, is multiplied by to get that number, and you write that number next so that you're going in increasing order from the smallest number to the largest number. And so the numbers on the very outside are multiplied by each other, and then a little bit inside, and then a little bit inside, and then a little bit inside, until the very two in the center are also multiplied by each other to get 15. So this is a method
Like
that
the outside, like 1 and 15 equals 15, and 3 and 5 equals 15.
Yeah, exactly. Yeah, so it's called the rainbow method because you have the big arch and then a smaller arch and a smaller arch, because each number is then multiplied by the other one on the other side. And I even still use this method even in 10th grade, so it's very useful. All right, so we are going to be doing a common factor maze. So the objective of this activity is that you are going to learn to apply your knowledge of factoring, all of these rules that you just learned for it, to solve a maze. You will match factors to the appropriate number and move through the maze.
I've done something like this, and it was a little tricky.
Yeah, it's very tricky.
Yeah.
Okay, so for this activity, you are going to need a paper and a pencil. So do you all have that in front of you? Yes, perfect. Okay, so the first step of this is to copy the maze that's shown on the next slide onto your piece of paper. So this is what you are trying to copy down. When you are both done with that. Done?
I finished.
Great.
I made it easier by only putting start, end, and the number instead of writing factor on each one.
That is easier. Yeah, that's a good idea. Very good idea. So now you are looking at each of the numbers. So in this case, the start right here in the top left corner where you're supposed to start, you are trying to find two of the factors of 16. So just looking at the number at first, what do you think it would be divisible by?
2.
Yeah, and then if you divide 16 by 2, what does that get you?
8.
Exactly. Is 16 divisible by 5?
No.
No. But it is divisible by 4.
Yes, but if it's but 16 divided by 4 is 4. So these multiples would have to be 4, 4 in order for it to be true. But 2 and 8 is given to you, and that one is already true. So you go from this number over to the 32. And then now you're looking at this, and what is 32 divisible by?
8 and
4
4.
and 8.
Yeah. Is it divisible? Is it divisible by 2?
Yeah.
What is the opposite multiple for 2 if you divide 32 by 2?
What do you mean?
Like you multiply 2 by to get 32.
16.
Yeah. So 2, 7 would not work because what's 2 times 7?
14.
Yeah. And that is nowhere near 32. So you go right from the 32 here, down here, and then I'm going to let you guys try and do the last few steps to get to the end on your own. And let me know if you want to talk through it or if you have any questions, but I'll let you do that.
I made it to the end.
Great.
Yeah.
Did you both make it to the end? Okay, so where do you go from 28?
I go to 4 times 7 because 4 times 7 is 28. And then the factor is 36.
Then 36.
And 6 times 6 equals 36, and then I go back to the end.
Exactly. Yeah, so it goes from 16 to 32, down to 28, down to 36, and to the end. Exactly. Good job, guys. Yes. And that was the solution. And then this one is a lot harder. So if you'd like to do this, definitely give it a try. I will give you a few minutes to try it. But this is a much harder one to help the dog get to the bone using only prime numbers.
This one's very big.
It is very big.
That's a lot to write.
I don't think I'm gonna write it. I'm just gonna use the screen.
Yeah. You can definitely just use the screen. So let me know if you need any help or anything.
Where does it start?
I believe it starts over here, but I'm not exactly sure.
Because that's
Oh, yes, it does start here.
okay.
Right on 109.
gone from 109 to 103.
Yeah.
I'm stuck at 104. Wait.
We're starting right at 109.
Wait.
And yeah, exactly like what Cal said.
Wait, are you allowed to skip numbers?
No.
But then 19 did not prime number.
It is actually.
But 19 is a factor of 9 and 2. And like 3 and 6.
Could you go diagonally?
No. 19 actually is not divisible by 2 because remember it's not even. And 9 plus 1 is 10, and that isn't divisible by 3, so that it wouldn't be divisible by 3 or 6. And 9 plus 1 is 10, and so it wouldn't be divisible by 9 either.
Oh.
Wait, could you go diagonally?
No, you can't.
Oh.
How about like 3 and 6? Those are even, like 60.
Yeah, 16 is divisible by, is not prime, but 19 is. So, I'm going to, unless you guys maybe want to try doing this further, there are other activities that we are going to be doing today, and so I can show you the answer for this because it's actually a very, very long route around. Is that fine, or do you guys want to try?
Yeah, it's fine.
Okay. We're going to move on. So you go down from the 109 to 119 to 103 over to the 113, and then up and around all of these numbers that the arrows are on. These are all prime, and so you had to take that whole long route around over to the 17 over here in order to get to the bone. Yeah. So
You're right, it was really long.
yeah,
Yeah.
very, very long. All right, so what did you find easy about the mazes, and what did you find that was difficult for you to do?
For the first maze, I thought it was easier than the second one because there was only like 3 places that you could go to.
Yeah.
And they were like more easier to like solve, like instead of the prime number one.
Instead of like finding the number and like doing the math and stuff, in the other one you can just kind of guess, I guess, because like you have to find the multiples, which is way easier.
Yeah, you had to like guess and check. Yeah, exactly. So these were a lot higher numbers, so there were a lot more possibilities of numbers that they could be divisible by. And yeah, the other one, I agree, the other one is much, much easier. All right, there we go. Okay, for our next activity, we are going to be doing a factoring game. So for this activity, you are going to learn how to solve a number of factoring problems to decode a secret message. So what you need for this is, of course, a paper and a pencil, which you both have in front of you, I'm guessing. All right, so the greatest common factor of something is the largest factor, that 2 numbers share. So for instance, for 42, the 2 largest numbers are 6 and 7. 7 is then not divisible by anything, only 1 in itself because it is prime, and 6 is divisible by 2 and 3. Have you guys heard of greatest common factor before? Have you used it?
No.
All right, so the reason that 42 has the greatest common factor of 6 and 7 is that even though it is divisible by 2 and 3 as well. The greatest numbers, the largest numbers that it is divisible by, other than 1 in itself, are very large numbers, but 6 and 7 are right next to each other. Because if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6 and 7 are right next to each other, and so that's going to be the very center of the rainbow when you find the multiples. So do you guys remember the rainbow that I showed you a little while ago, where you write out 1 and 2 and 3 and all the multiples of a number, and then you have the opposites on the other side, so then you connect them together. So the numbers on the very inside of that rainbow will be the greatest common factors. So we'll do a little practice with it. So examples of greatest common factor. The greatest common factor of 6 and 9 is 3, because if you have the factors of 6 and the factors of 9 and you line them up right next to each other, so 6 has factors of 1, 2, 3, and 6. And 9 just has the factor of 1, 3, because 3 times 3, and 9. And so 3 is the largest number that they both share as factors. They don't have, 6 does not have a 9, and 9 does not have a 6, and they both have 1s, but they both have 3 also, and 3 is larger than 1. So 3 is the greatest common factor of these two numbers. Does that make sense? Sort of?
Yeah.
Great. Okay, so 48 and 24. This is a little more challenging, but just listing out all of the factors. You have 12s and you have 24s, you have 8, 6s, 4s, 3s, 2, 1.
The greatest common factor would be 24.
Exactly. So 24, they have it in common. It's the largest number that they both have as a factor. So it's called the greatest common factor. The largest common factor. And the least common multiples are the smallest multiples of two numbers. So it's the very opposite of what we just learned. Instead of the greatest number that they have in common, it's the least number that they have in common. So the smallest number that they have in common. And so finding the least common multiples of 3 and 4. So least common multiples, you have to multiply 3 and 4, like 3 times 3 times 3 times 3 times 3. You multiply that, and then you see what's the first number, the very first number that they both have in common. So what numbers, as you can see here, do they have in common?
I remember doing this when I was in class doing math, when it was adding fractions with an unequal denominator.
Yeah, exactly. Yeah, you have to use that for adding fractions, exactly.
Multiples of 3. Never mind.
So what is the least common factor of 3 and 4?
12.
Yeah, 12.
12, exactly. So they don't have 3 or 4 in common, because 4 does not have 3 and 3 does not have 4. Mm-hmm. They don't have 6 or 8. 4 does not have 9, and then they both have 12, exactly. So the smallest, the least common multiple is 12. In word problems, you have to figure out whether you're supposed to use the greatest common factor or the least common multiple of numbers. So least common multiple will be for an event that is repeating or happening multiple times, or when or determining how many items to purchase to have enough for a certain event that you are planning, or something like that. Or there are this many people and they each have this many, and they each need this many of something, of napkins. And then you are figuring out how many packs to buy in order to have enough for all of them. And also to figure out when two events that take different amounts of time will happen at the same time if they occur at the same time. The greatest common factor, which is where you find, what's the least, or the greatest common factor of 12. You're figuring that out for word problems. If you're splitting things into smaller sections, if you're trying to equally distribute items between a certain number of people or a certain number of places, and if you're trying to arrange something into rows and columns. So there's a lot, but we're gonna we'll look at a few examples. We are going to try some word problems. So for this first example, you are making a board game that is 16 by 24 inches. You want to use square tiles that have equal length and width. So what is the largest size for the tiles that you can use? So in this example, do you think you would use least common multiple or greatest common factor?
Least common multiple.
In this case, you're actually, yes, exactly. Greatest common factor, actually. So you're looking at 16 and 24, and you're looking at the factors of each of those individually, and seeing what the largest size, what the largest number there is that they have in common. So that's called the greatest common factor. So in this case, what would be the greatest common factor of 16 and 24? Do either?
12?
What?
12?
16 is not divisible by 12, even though 24 is. Yeah. So you're very close though. Are both of them divisible by 2?
I think it's 8 maybe.
Yeah, 8.
Yeah, it's 8, exactly. So you are using greatest common factor, as we said, and so the factors of 16 and 24 are listed here. And yeah, you have 8 and you have 8. So 8 is the largest, and so the largest squares that you can use are 8 by 8 inches. All right, so for the second example, wait, let me see. Let's just go. Okay, so for the game that we are going to play, the goal of this game is to decode a secret message using least common multiple and greatest common factor. So basically, there are going to be 9 numbers, 9 bullet points that come up over here. And so you have to find each of those numbers, and then they correspond to a letter, and then you put the letter down down here to find what the message is. So what is the greatest common factor of 13 and 26?
13.
Yes, exactly. Because 13 and 1 for 13 and 13 and 2 for 26. So what does 13 correspond to on this chart?
M.
Yeah.
M.
So M. And then all prime numbers have this factor in common.
1.
Yeah, 1 or 0.
0.
Oh, themselves. No.
Yeah. So 1 exactly.
Yeah,
It's only 1.
The one is A.
Yeah. So far we have M and A.
I think that word might be math.
Let's see. Greatest common factor of 40 and 60.
I think the secret message maybe make it now.
30.
That
30 is not a factor of 40, sadly.
Oh, yeah.
What is another?
20. Yeah, 20.
20, exactly. So far we have MAT. If you have two pieces of fabric that are 32 inches and 24 inches, what is the largest square that you can make out of both pieces of fabric? The largest square. So is that greatest common or least common multiple or greatest common factor?
Greatest common factor.
Yeah.
16.
24 is
Yeah.
divisible by 16. Yeah.
I was thinking 12, but I don't think that will work.
Yeah.
Not for 32. Yeah, it does work for 24, but not for 32.
2?
4.
4 is 1, but it's
Wait,
not
8.
the greatest.
8?
Yeah,
8.
exactly. 8. So 8 corresponds to which letter?
H. So math.
H. Yeah. So we have math. What's the greatest common factor of 9 and 18?
9.
9.
Yeah. So that corresponds to an I.
I think that's what it is.
That is
What the second largest prime number from 1 to 26? So you have 26, 25, 24, 23 is a prime number. 22, 21, 20, 19. 19?
17.
Yeah, but 19 is the second largest.
Oh.
So that corresponds to an S.
It's fun. It's probably maybe math.
So if you run 2 laps per minute and your friend runs 3 laps per minute, how long until you both run the same number of laps?
6 minutes.
Yes. Exactly. 6 minutes. So that corresponds to an F.
Yeah, it definitely is math. It's fun.
No, it's F.
What are 3 and 7 multiples of?
3 and 7 are multiples of 21.
Yeah. So that corresponds to U. And what is the greatest common factor of 14 and 28?
14.
14.
Yep.
Math is
The
fun.
message spell out? Yep.
Math is fun.
Is math fun?
Yes.
Yes.
I think so. Okay, do you guys have any questions about that?
No, that was really fun.
I agree. Yeah, so here are all the answers, but we went over it already. And we actually do not have enough time for this. It went by so quickly, but I hope you guys had fun. Let's see. If you both want to do a last one, we should probably do a debrief. So,
What's a debrief?
it is talking about what we talked about. It's talking about what we talked about during the workshop. So what are some tips or tricks that you have learned about factoring, or like how to factor specific numbers?
I don't really know any.
I learned that 2, for it to be a factor of 2, it has to be even.
Yeah.
Yeah. What else?
And for it to be a factor of 9, it has to be, if you add up the numbers together, it should equal 3, and 3 is the factor of 9.
It should equal a factor of, it should equal a multiple of 9.
Yeah.
Yeah, exactly. And then what about for 6?
6, it has to be even.
Has to be even.
Yeah.
Has to be a multiple of 3 and 2.
Yeah.
Exactly. Yeah. So it has to be a multiple of 3 and 2, and if it is, then it is divisible by 6.